Good afternoon, students. Welcome to today's session. So today we are going to discuss a very important concept in physics, that is projectile motion. Those who are preparing for JEE and the NEET exam, so you may expect one question from this chapter. Okay, projectile motion. So this is a very applicable for our day-to-day life concept. Okay. Already we know the many types of motion: linear motion, circular motion, rotational motion. Okay, similarly the projectile motion is also one of the motion. Today afternoon and tomorrow afternoon we are going to discuss only this projectile motion. On Friday Zoom class, a very important 5-mark question related to this projectile motion I am going to teach in online. Through live we are going to discuss. Okay, so don't miss this opportunity. Now we will discuss about projectile motion elaborately. Let's see the projectile motion. Students, first of all, we are going to see the introduction of the projectile motion. So what is projectile motion? When an object is thrown in the air with some initial velocity, that is, if we throw any object with few speed or few force, then it is allowed to move towards gravity. That means the object will be fall on the ground, and this is known as projectile, and the path reached by the object to reach the ground is known as trajectory. Okay, that is in which direction the object reaches the ground, that whether it may be a parabola or any semi parabola, that is known as what? Trajectory. Next, see the sum of the projectile motion. The first one, an object dropped from a window of a moving train. Now you see the object reaches the ground. The path of the object reaches the ground is known as projectile. Then second one, a bullet fired from the rifle. Then a ball thrown in any direction, that is, if you are playing a cricket or football, now you kick the ball or hit the ball, now the shape of the object reaches the ground, that is a projectile. Then a javelin or shot put thrown by an athlete. Then a jet of water issuing from a hole near the bottom of the water tank. So these are some examples of the projectile motion which we discuss in the, or which we see in our day-to-day life. Students, when the object in the projectile motion, that is, when an object is said to be a projectile, the object attains two velocity. The first one is horizontal velocity, that is in the x direction. The next one is vertical velocity, that is will be the y axis, that is against the gravity. Okay, now you see a uniform velocity in the horizontal direction. So always the velocity will be constant in horizontal motion, so there will be no change. Okay, also we never consider the air resistance, that is we never calculate the air value. Next one, a uniformly changing velocity, that is the movement of an object in the y direction is considered as a vertical direction. Okay, that will be increase or decrease its velocity. So these are the two velocities, the horizontal velocity and vertical velocity. There are two types of projectile motion. Okay, one is horizontal projection and another one is angular projection. Let's see the horizontal projection. The projectile given an initial velocity in the horizontal direction, so which is known as horizontal projection. So that is, in object thrown only from the top of the height it reaches the ground, that is known as horizontal projection. Then angular projection means the projectile given an initial velocity at an angle from the ground to it reaches the certain height and it will be reaches the ground. For example, the goalkeeper kicked the ball from the lower region to the another region, that is a angular projection. Students, an important point you have to remember when you are going to study the projectile motion. So you never consider the air resist value, that is you never calculate the air in the atmosphere. Second one, the effect due to rotation on earth and center of curvature of earth is negligible, that is you never consider the atmospheric rotation of the earth surface. Third one, the acceleration due to gravity is a constant, that is in our earth surface the object reaches the ground, so it will be constant in all the projectile motion. Students, first we are going to discuss about the projectile motion in horizontally. Okay, that is horizontal projection. So what is horizontal projection? When an object is thrown from a certain height and reaches the ground, so this type of motion is known as horizontal projection. Okay, see the example, a ball thrown horizontally with an initial velocity, that is u, from the top of the tower height h. See this diagram, you may understand the horizontal projection. Here the object is placed at the height of O, from the ground surface to the height of the object is h. Initially the velocity will be equal to 0. Okay, now after some velocities and the object reaches the ground, it reaches the point A through the path of P. Now the distance from that object to the reach the point is known as range. Okay, so how far the object covers the distance from the initial point to the final point, that is called range. See this another diagram, this is also example of horizontal projection. Suppose if we have to calculate any time or velocity or distance traveled by the object or height of the object, only by using the kinematic equation we can find the value. Okay, so using this kinematic equation in both x direction and y direction separately. Okay, for example, the projectile motion takes place in the two-dimensional, so the component, that is the velocity, will be divided into horizontal velocity is represented as u of x and vertical velocity is represented as u of y. Okay, so first I am going to calculate the motion along the horizontal direction, that is the object covers in the horizontal path. Horizontal means the x direction. Okay, now always the horizontal direction, the horizontal velocity is represented as u of x. Here always the acceleration will be equal to 0 in horizontal direction, and t represents the time taken to cover the distance. So how to calculate the distance covered by the object in horizontal direction? Only by using the kinematic second equation, that is equation of motion. So we know the formula, s equal to ut plus of at square. So now the object covers in x direction, so the equation will be converted into s of x equal to u of x into t plus e of at square, and substitute the values where s of x equal to x and a equal to 0, and substitute in the above term. So we get x equal to u of x into t plus 0, that is anything into 0, 0. Therefore x equal to u of x into t. So this is equation number 1. Next we are going to find the motion along in the downward direction. Downward direction means after it reaches certain height, all the object reaches the ground due to the acceleration due to gravity. Okay, so now we are going to calculate the downward direction. Again we are using the same formula, the second equation of motion, s equal to ut plus of at square. Now the object covers in the y direction, so the equation will be converted into s of y equal to u of y into t plus at square, and substitute the value where s of y equal to y and u of y equal to 0 and a equal to g, that is now the acceleration will be converted into acceleration due to gravity, and substitute the known values, we get y equal to 0 plus of gt square, or simply we can say y equal to of gt square. This is equation number 2. Now coming to first equation, we know x equal to ux into t. For calculating the time period, we know t equal to x by u of x. Okay, so here we are having t square, therefore we can convert the value into x square by u of x square. Consider this is equation number 3 and substitute equation 3 in equation 2, which means substitute the t square value and we get y equal to of g into x square by u of x square, and taking the x square outside because it is variable changing and other terms are constant, so the constant terms are keeping as a separate thing, therefore y equal to g divided by 2ux square into x square. Since this term all equal to constant, therefore we can replace that value as a k and substitute the above equation, we get y equal to k x square. So this final equation represents the parabola, that is the final equation looks like a parabola. Then we confirm that when the object is thrown, we get the path of the projectile, that is the object covers the distance in a projectile motion. Students, now we are going to discuss what are the possibles to study when the object covers the projectile motion. The first one is time of flight. So it is nothing but time taken by an object to reach the ground or reach the point, that is known as time of flight, or otherwise the time taken by the projectile to hit the ground is known as time of flight. The time of flight is represented by capital T or T suffix F, that is a time of flight. Now we are going to calculate the time of flight of an object to hit the ground. So consider the object at the height h, time taken to reach the ground is capital T. Okay, now we are going to calculate the time period by using the second equation of motion, where s equal to ut plus of at square. Now the object in the y direction we are replacing as s of y equal to u of y into t plus of at square, and substitute the value or replace the value where s of y equal to h and small t is replaced as capital T and u of y equal to 0 and a equal to g, and substitute all the value in the above equation, we get h equal to 0 into t plus of gt square. Now since anything into 0 we get 0, therefore h equal to of g t square. Since we need only the time period, so rearranging the formula we get t square equal to 2h by g or t equal to square root of 2h by g. So what is the conclusion? That is the time of flight of the projectile depends on the height of the tower. Okay, suppose if the height is increased, the path also increase.